Now I am telling you about the Meissner effect and the persistent current. This phenomena is related with the superconductivity. Meissner effect is related to the phenomenon of superconductivity. Superconductivity. Meissner was a German scientist. Now this we know that when the temperature of the conductor is increased, its resistance also increases. But if we do the reverse of this, that if the temperature is reduced, then the resistance of the conductor will reduce. If we continuously decrease the temperature of the conductor, then we will reach at a certain critical temperature at which the resistance of the conductor vanishes and the conductor becomes the superconductor. When temperature of conductor is decreased continuously, it is found that at certain temperature, the resistance of conductor becomes zero and its conductivity is infinite. This lowest temperature at which the resistance becomes zero is called critical temperature. Critical temperature. Denoted by TC. The critical temperature TC is different for different materials. Different materials. So the critical temperature differs from element to element. For example, critical temperature Tc for mercury is equal to 4.2 K. 4.2 K. This phenomenon was discovered by kaons in mercury. So let T equal to temperature of conductor and Tc the critical temperature. Then what we have? If suppose we are having this material, this is the what that we have the superconductor. This is superconducting ring. This is superconducting. This is the magnetic field B. Magnetic field B. This is when T is greater than Tc. But when T is less than Tc, then what happens? Similarly, this will not be magnetic field. Then this is the superconductor. Here we have this superconductor in which lines of force are passing. Now this is when T is less than Tc. T is less than Tc. Meissner found that at T greater than Tc, there is magnetic flux passing through conductor, and at T less than Tc, the magnetic flux is excluded. The magnetic flux is excluded by superconductor. Superconductor. This effect is called Meissner effect. This is called Meissner effect. The exclusion of the magnetic flux by the superconductor is called the Meissner effect. So what we have, that integration B dot dA, this is equal to 0. So this says that there is no magnetic flux through the superconductor. At T greater than Tc, a potential difference is applied on the conductor. There is flow of current in the conductor. Now, according to Ohm's law, V equal to IR, R the resistance. And this I is equal to V upon R at T less than Tc, R equal to 0 or I equal to infinity. R equal to 0 and I equal to infinity. It does not mean that the strength of the current will increase, but it means that current will exist for a long time. The current through superconductor will continue to flow for a very long time without any loss of current without any loss in its strength. It means that suppose initially the current was 1 ampere, then at t less than tc, the current will also be the 1 ampere, and this 1 ampere current will flow for a very long time. And such currents which continue for a long time are called the persistent currents. This current which exists which flows for long time in superconductor is called persistent current. Persistent current. So the current through the superconductor will continue to flow for a very long time without any loss in its strength. This current which flows for a long time in superconductor is called the persistent current. तो अब स्टूडेंट ये पूछते हैं कि भाई अगर इसमें रेजिस्टेंस इसका 0 है तो इसमें करंट कैसे फ्लो होती है। हम यहाँ से देख रहे हैं I इक्वल टू P अपॉन R का मान इसमें 0 कर दो, I का मान इन्फिनिटी हो जाएगा। I का मान इन्फिनिटी होने का अर्थ ये कदाप नहीं है कि इसमें जो करंट है उसकी स्ट्रेंथ बढ़ जाएगी, जैसे 1 एम्पीयर करंट जा रही है तो ये सुपरकंडक्टर होने के बाद भी 1 एम्पीयर ही रहेगी। ऐसा नहीं है कि 1 एम्पीयर की बजाय 10 एम्पीयर हो जाए, 100 एम्पीयर हो जाए। दिस इज नॉट सो। द करंट विल बी ऑफ द सेम स्ट्रेंथ एंड दैट विल कंटिन्यू फॉर ए वेरी लॉन्ग टाइम। सो दिस करंट एग्जिस्ट फॉर ए लॉन्ग टाइम इज कॉल्ड द persistent current. This I is equal to 0 only means that the I is equal to infinity. I is equal to infinity. This V is not equal to 0. V will not be equal to 0 because we have applied the potential difference across the conductor. So that V is not equal to 0. Only 0 is the resistance. That is making the current to be infinity. So the current exists for a long time. This is what the persistent current. So the superconductors are very useful because the current can be maintained for a long time without any loss of power, without any electrical energy loss. So we can have this current for a very long time. But since the maintenance of very low temperature is not possible, so these cannot be maintained in our daily use. So this is what that the superconductor are not available at the room temperature. If however we obtain the superconductor at the room temperature, then definitely all these circuits and the big electrical appliances, just like the transformer, TV, etc., they are so much big, they will be converted into a matchbox size. So this superconductivity is very useful, but its maintenance of low temperature being very typical, they cannot be have at the room temperature. So this is about the Meissner effect and that the persistent current. So thank you very much.